So the purpose of this video is to try to give you an approach to problem solving with acid-base equilibria. The biggest challenge with acid-base equilibria problem solving is trying to figure out what the question is asking for. So you have to ask, what do I know? What do I need to find out? The kinds of questions you're going to ask yourself are, is it a buffer? Is it a titration? Or do I just have a simple weak acid or weak base problem? Once you figure that out, the problems are actually pretty straightforward. Be patient, look at each problem uniquely, and whatever you do, don't try to memorize how to do problems. There's too many different types and you'll never manage it. Instead, here's an approach to follow that I think works well, and students tend to agree. So, first thing you're going to do is ask yourself, what do I have? So here's an example question. If the answer to your question is a weak acid or a weak base, then you make your icebox and you complete the problem just as we've learned. Okay, so for instance, what is the pH of a 0.5 molar solution of NaF? Okay, well, what is NaF? Right, it's Na plus and F minus, and we don't really care about the Na plus, right? So the answer to my question is, I have a weak base. If I have a weak base, I make an icebox. Okay, so I take my F minus, right, add it to water, HF, OH minus, ice, right, 0.5, we don't care about the water, 0, 0, minus X, plus X, so you've done a bunch of these, 0.5 minus X, X, and X. You're going to need the KB for F minus, okay? So it is 1.4 times 10 to the minus 11. You'd either be given that in a problem where you'd have a table of them, okay? So that's X squared over 0.5 minus X. Of course, we're going to make our assumption since KB is so tiny. And when you do that, you get X is 2.6 times 10 to the minus 6 molar, and keep in mind that it's OH minus, right, because it's OH minus. So first thing we'll find is the POH, which is 5.58, and the pH is 8.42. So if you see a problem like that, it's just like what we did in the last chapter, so no big deal. If the answer is that you have both a weak acid and its conjugate weak base, then you have a buffer. So all you're going to do then is just fill in either version of the Henderson-Hasselbalch equation. Okay? So for instance, what is the pH of a solution containing 0.5 moles of HClO and 0.25 moles of KClO? So again, I've got a weak acid and its conjugate weak base. And as I've told you, my preferred form of Henderson-Hasselbalch is going to be the simple version. You can use the other one if you want. I just think this is easier. Okay, so we can do moles of acid. Let's see, our acid is this, over moles of base. So once you discover that something is a buffer, it actually becomes quite easy. You just plug in here. And then once you got your H plus, you find your pH, and your pH here is 7.25. So pretty easy as far as that kind of problem. If you're adding, okay, in the problem, if you're adding strong acid or strong base to something, things are actually going to get a little bit more complicated. You're going to need to start by making an ICF box. This is different than an ice box. The F stands for final, and it's written for a reaction that goes to completion, okay? And it's not an equilibrium reaction, and you need to use moles. So for ice, you need to use molarity or atmospheres. For ICF, you need to use moles. And it's just a way of keeping track of the stoichiometry. We'll do some problems with this. So once your ICF box is complete, you look at your final row and you ask yourself again, what do I have? If you have both a weak acid and a weak base, you've got a buffer, and you fill in the Henderson-Hasselbalch equation. If you're at the equivalence point, which would mean you have no reactant remaining, both of the reactants are now 0, your product will end up being either a weak acid or a weak base. So you make an icebox, okay, like we just did. The only extra difficulty here will be that you'll need to find the concentration of your weak acid or weak base, and this means you first need to find the total volume. But don't worry, we'll do some problems with all of this. This is just to give you a general approach to problem solving.